Show work for each problem according to the directions, solved by factoring and finding square roots. So number one, we got to get everything to the same side in order to factor. When we factor, we compare stuff to 0. We don't compare stuff to 3. This is a zero product property. And with a trinomial, we're going to factor this into two binomials. We have 2x and x. That's the only way we're going to get 2x squared. And then we have to fit 3 in there somewhere, negative 3, to get a positive 1. Well, I'm going to get it wrong. But that's an option. That's going to be negative 6 and positive 1. That's negative 5. There's not a negative 5 in the middle. It's the middle that matters. That where as long as you're using the correct factors, we want to get the middle. All right, so that didn't work out. How about plus 3 and minus 1? That's negative 2 and positive 3. That's a positive 1. We got it. So 2x plus 3 equals 0. That's a possibility. Negative 3. X is equal to negative 3 halves. Minus 3 and divide by 2. And then 1 makes the other one 0. 1 minus 1 is 0. So there's the two solutions. Gotta get that middle number right. Solve by factoring and finding square roots. So we have two choices on this. These are both perfect squares. 5x plus 8, 5x minus 8. This is called the difference of two squares. And if you do the outside and the inside, you get 0. There's no x. There's a 0x in the middle. We could write this as 25x squared plus 0x minus 64 equals 0. So that's where you get the 0. Negative 40x, positive 40x. So now we have 5x plus 8 equals 0. Subtract 8, divide by 5. Negative 8 fifths. And over here we have 5x minus 8 equals 0. Add 8 and divide by 5. 8 fifths. So it's really plus or minus 8 fifths. Let's stay on this one a little bit more. Write this down for me, please. I could add 64 over. There's an option to this one because we don't have the x. If we don't have the x, we have options. We have perfect squares, and this is an option also. I can divide by 25. Then square root both sides. What do we need when we square root both sides of an equation? Plus or minus, right? We would never forget that. There's plus or minus 8 fifths. We have the positive and the negative answer. So in that one you have options because they are perfect squares. All right, let's keep rolling along. What's different between number 1 and number 3? What's the difference between, other than the obvious numbers, what's the big difference? You don't have the c, right? You don't have the constant. That's the big difference other than different numbers. I get that. No constant. When there's no constant, you factor out what you can. 4x. 2x minus 3. We can't do this process. We can't do that process when we don't have all three terms. You'll try, but you're not going to get it right. You just got to factor out what you can. And we don't do this one as much. That's why I'm kind of emphasizing it. Well, here's a trick question. What makes x 0? 0. So x equals 0. And then over here, we got a little bit more work to do. 2x minus 3 equals 0. Add 3. Divide by 2. 3 halves. So 0 or 3 halves. Sometimes that x there can be a little tricky. Not negative 4. Why would I not put negative 4 there? That's not 0, is it? 4 times negative 4? That's not 0. So it's 0. All right. Hopefully I've emphasized that enough. What would you do first on 4? I know what I would do. Divide by 2. Because everything's divisible by 2. So x squared plus 2x minus 8 equals 0. And I would like you to rather just think about factoring it out. Because then when we don't have equal to 0, if the 2 goes away, that's not right. So I would just consider factoring it out. Now we have 2 times the 2 parentheses. Because now we have all three terms. If we have all three terms, we need sets of parentheses. Over here, we don't. So that changes things a little bit. So x plus 4, x minus 2. X equals negative 4, x equals 2. That's what makes those 0. Now, you can't make 2 0. That's impossible. The reason we had 0 over here is because it said 4x. 4x is much different than just having a 2 there. So one of the answers is not 2, because you can't make 2 0. Now, what's the difference between, and I know this says 4x squared minus 13 equals 0. Go ahead and write that down, please. First of all, please write the problems down. You guys are a good class, you really are. Everybody participates. It makes my life so much easier. So thank you very much for just being just a good class. All right, anyway. What's the difference between number 2 and number 5? They're almost, I know the numbers are different, but that's kind of the issue. They're not perfect squares, are they? Is 13 a perfect square? No. So I can't factor this one using difference of 2 squares. I can't do that. I don't have a choice on this one because 13 messes that up. 4x squared doesn't mess it up. That's a perfect square. 13, naughty. It's making me do only one way. Plus 13, plus 13. 4x squared equals 13. X squared equals 13 over 4, right? Divide by 4. We're going to square root. Now, if you can square root, you must. If you can't square root, then don't. I don't want decimal answers unless it specifically says. Now, we can't square root 13 and get something nice. We can get a decimal, but we're not talking about that. But square root of 4 is 2, so that's the answer I'll be looking for a complete answer. To get full credit, I want to see that 2 down there. Notice on this other one, up here, I was able to square root both of those. I know what the square root of 64 is, that's 8. And I know what the square root of 25 is, that's 5. That's because they were both perfect squares. All right, let's investigate this. Give me a second now. Give me your attention. Let's investigate this page a little bit. We have a nice trinomial. That factors into 2 parentheses, 2 binomials. We have a choice when they're all perfect squares. We can do difference of 2 squares, or we can do square roots. Ends up being the same answer, of course. All right, here's the big one right here. We don't have the c there, so it changes it a little bit. You got to factor out what you can. That's the difference. No c. Don't put the parentheses when you don't have a c. I see that a lot. Speaking of c. Factor 2 out, and then not all perfect squares on the last one. I tried to pick about every situation you're going to encounter. That's how I roll. Oh, it's switching today. It wasn't last period, so it has a mind of its own. Solved by completing the square. CTS, complete the square. Please jot that down. What is the first step on this one? Divide by 2, right? Not minus 8. Minus 8 is not the first step. Now, if that 2 wasn't there, we would minus 8 first. But this changes things. And on this one, I do want you to divide by 2 and get rid of it. All right, that's the first step. You can't complete the square if a is not 1. It has to be 1. Okay, now what? Minus 4, right? We got to get that 4 out of there. It's ruining stuff. So we have x squared plus, it's ruining the perfect square. Negative 4 plus something. That's how we complete the square. We add stuff in. We add extra stuff in. What do I add to both sides? 1, right? Take 2 divided by 2. Square that. 2 divided by 2 is 1. Square that, it's 1. We're adding 1 to both sides. Now this factors into x plus 1, which is x plus 1 squared. That was the whole purpose, to find what adds to 2 that's the same number. It's got to be the same number. Equals negative 3. Right, Maddie? Right. So next step. Square root, right? Square root. And what are we not going to forget? Plus or minus. Plus or minus I square root of 3, because it's negative. We're square rooting negative. That's imaginary. I want to see the I. X equals negative 1 plus or minus I square root of 3. There we go. Don't have to simplify or anything. Now, if we had negative 1, write this down for me. If you end up with something like that, there's a little extra. You're done with the completing the square, except there's always this little extra piece that you got to be aware of. You got to look at the radical and say, am I done with this? Am I done with the radical? No. You have the I, of course. But not only that, there's a little extra in that this is 4 times 6. Square root of 4 is 2. We put the 2 there. And then the square root of 6 would be a decimal, so we just leave it. So that'd be a little extra. So sometimes you're not quite done with the process of completing the square. You always have to be aware of that. Sometimes you just have a little more work to do. Awesome. Finally solved by quadratic formula. You have to have this memorized. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And we don't just pull that out of the air. We didn't make it up. It comes from a process. The process is completing the square, which is a, b's, and c's. So it comes from somewhere. All right, but it's pretty straightforward in that we just start plugging in values. Your a is 3, your b is negative 2, and your c is 4. Now remember, your b is negative 2. Don't forget the negative. Well, this negative b doesn't mean that it's always negative. It means it's opposite of what it is in the equation. So 2 plus or minus square root of. Negative 2 becomes positive 2. B squared is 4 minus 4 times 3 times 4. All over 2 times 3. So there's the 2a. All right, so we got some simplifying to do. 2 plus or minus square root of 16 times 3 is 48. If you can't get that number out of the radical using your calculator, you better ask somebody. Yeah?
Should the 2 times 3 be negative 2?
2 times a.
The bottom, yeah.
That's 2 times a. A is 3.
No, no.
Yeah, not negative 2. It's not the b. It's not. You're thinking b times a. It's always 2, okay? All right. So 4 minus 48 is negative 44 over 6. Now, we've gotten to the point where we're pretty much done, with the exception of, are we done with the radical? That dang radical. It just makes us do more work, and yeah, we got more work to do. Not only that, if you have this answer so far, if you have 2 plus or minus the square root of negative 44 over 6 like that, that is very wrong. That's very wrong. The 6 is underneath all of it, not just the radical. All of it. I want to see the left side, not the right side. All right, anyway, let's look at square root of negative 44. First of all, that's I. And we have 4 and 11 in there. So the I takes care of the negative. Square root of 4 is 2, but the 11 stays underneath. Square root of 11 would be a decimal. All right, so here's what we have. 2 plus or minus 2i square root of 11 over 6. Are we finally done now? No, we're not done now, because all of those are divisible by 2. They're all divisible by 2. Dang, this one takes forever. This one's a long one because you're not just done when you do the quadratic formula. So those 2's, when you divide by 2, that's 1's. And no, the 2 didn't go away. It became a 1 here. Right there, it became a 1. And then 6 divided by 2 is 3. Now we're done with this one. A little extra work to be done. You got to look for that. I think that's all I have. Oh, no, I do have some more. Good. I'm loving this. A few more. These go quick. This one's just simplify. 16 times 2. 16 is in there. Now, if you're like, let's do it this way. I'm going to change my mind. I'm going to do it like this. What if you didn't realize 16 was in there? And that's a common, not error, but just common thing to go, oh, that's 4 times 8. Let's do it that way. Let's go 2 plus. Square root of 4 is 2. It's negative, so I. And we have square root of 8 in there. Now, if you leave it as square root of 8, that's not complete. You're not done, because there's another 4 in there. That's why we can take 16 out at the beginning, because you can take 4 out twice. 2 plus 4i square root of 2. Right, Maddie? You write this down? All right. That's a complete. Now, if 4 is in the end, that means you can take 16 out at the beginning. All right, here we go. FOIL. Got this one jotted down? I'm sorry, I forget, I didn't hand you this, so I'll try to go fairly slow. We got 8 plus 14i inside minus 12i. Now here's the tricky part, I think. The first few are fairly straightforward. Now we have minus 21i squared. Anytime you see I squared, that's negative 1. So anytime you see I squared, you can just make it the opposite sign. So this is really 8 plus 21. So we have 29 plus 2i. 14 minus 12. I squared is negative 1. So you make it the opposite sign, times negative 1. This is the one I messed up a few days ago. Remember that when I foiled it? I didn't realize there was a minus in the middle. Don't do that same mistake, of course, on the test. Be careful and notice that there's a minus or a plus in there. Don't foil, of course. That's 2 minus 4. So the real part is negative 2. And negative 3 minus 7, right? Negative 3 minus 7, that's negative 10i. It's just you subtract its pieces, its parts. You subtract the real part, you subtract the imaginary part. Be aware of that plus or minus in the middle. All right, finally the last one right here. We have to simplify this, which means rationalize the denominator. Get the denominator to be nice, not complex. We do that by multiplying 2 plus 3i. If it's 2 minus 3i in the denominator, we're going to multiply by 2 plus 3i, the opposite. It's called the conjugate. There's a name for it even. Conjugates. Let's distribute the 3i through. We get 6i plus 9i squared. What's I squared? Negative 1. So that becomes opposite. So this becomes 6i minus 9. There's the top. The bottom is the difference of two squares. It's 4 minus 9i squared, which is 4 plus 9, which is 13. Now you're like, well, how come you didn't FOIL? Well, I did. But the outside is positive 6i. The inside is negative 6i, right? If you don't get that, if you don't remember, just write it all out. That's okay. Because the middle is going to be 0. That's why we use the conjugate. It'll always be 0 in the middle, because we're picking the conjugate. Now, if that was 6i minus 9 over 12, that would have been a better problem. Now all three of those are divisible by 3. So you'd have to make it 2i minus 3 over 4, but that wasn't the case. That's the answer right there. Look for simplifying radicals. It's not the big picture you guys miss. It's the details that students, not you guys, that students in general miss, the details. That's the difference between getting a 90 and a 93. How detailed are you? Can you see every little piece? So simplify those radicals. Can you divide all 3 by something? That'll miss you a half a point. That's the difference between a 1 and a 2. Or 2 and a 3, whatever order you're on. Okay? That's what I got for you today. Bye, YouTube. See you later.